Hello everybody, and welcome to the beginning of section 2.5. We are looking at page 48 of the workbook, and we're going to be continuing in this section and introducing yet another technique for finding derivatives of functions. Now before we dive in and talk about what this chain rule is all about, I want to just kind of take stock of where we're at in the course to this point. Okay, I'm going to scroll up, and I've made a little summary of previous derivative formulas that we already know. This is not a complete list, but it's kind of a list of the major ones. Okay, so you can see this is a pretty good list of functions that we have. Okay, kind of working our way down it, we know how to take the derivatives of x raised to constant powers. That was the so-called power rule. Exponential functions, a to the x and e to the x, and then various trig functions, sine, cosine, and then we had formulas for some other ones. And then most recently, we talked about the product and the quotient rule, rules for taking the derivatives of products and quotients of functions. Okay, so like I said, that's a pretty good list that we already have, but there are a lot of functions, it turns out, that we either can't take the derivative of using these formulas, or where it just wouldn't be practical to use our formulas that we have so far. Let me give you an example of what I mean. So we're going to scroll down here. Okay, and take a look at example 1. So what if we took the function y equals 3x squared minus 2x minus 5 to the fourth and tried to take the derivative of that? Could we do that using the derivative formulas we've already talked about? Well, you might look at that function and think, maybe we could use the product rule or the quotient rule, but if you look a little bit more carefully, this doesn't really fit either of those two forms. What's really going on here is that we've got a function, 3x squared minus 2x minus 5, raised to the fourth power. It's like having a function inside of another function. It's a function composition. So how do we take a derivative of something like this? Well, it turns out there's a nice rule called the chain rule that helps us to do this. Okay, let's talk about how that works. So what we're going to do is take this function on the inside and just give it a name. I'm going to call it u. Okay, so we'll let u be the 3x squared minus 2x minus 5 that's on the inside. And then notice that if we call that inside part u, our whole function becomes y equals u to the fourth. Okay, that's just a shorter way of expressing our formula. I'm going to underline that and label it whole function, because you'll hear me use that word a couple of times as we go through this. Okay, and to take the derivative of that function, what we're going to do is to just break the derivative into two parts. Okay, so the derivative of y with respect to x can be broken down into the derivative of y with respect to u times the derivative of u with respect to x. Okay, where does that formula come from? Well, think cancellation here. Okay, so these two du's cancel, and notice that what happens is we get a dy dx on both sides of the equation. That's kind of what makes that formula work. Okay, now what is the formula asking us to do? Well, let's take it one step at a time here. So the first piece says, take the derivative of y with respect to u. Where is our y? Well, that's sitting right here. So how do you take the derivative of that function with respect to u? That's just u to the fourth power. So by the power rule, we're going to get 4u cubed. Okay, and then we come to the second piece, du dx. That's asking us to take the derivative of our u, which is sitting over here. And so if we take that derivative with respect to u, we're going to get, derivative of 3x squared is 6x. And then the derivative of minus 2x is minus 2, and the minus 5 goes to 0. Okay, so we've taken the two derivatives that we saw, and one more step that's kind of customary here. This would be a kind of a weird way to leave our answer, because we've invented a new variable u, so it's customary at the last step to remind ourselves what that u is equal to and substitute it back in. Okay, so instead of writing u, let me be a little careful with space here. We'll write the u as what it was equal to at the beginning, 3x squared minus 2x minus 5 cubed times 6x minus 2. There's our answer. Okay, so let's talk about just the pieces of this. Okay, we're gonna work through a lot more examples of this. This process is a little bit strange the first time you see it, but there are basically two pieces to this answer that we have. Space is a little bit tight here, but I'm going to try to kind of squeeze this in. So if you look at the first piece, the first of the two derivatives that we took, this part here that I'm underlining on these two lines, that was, you can think of as the derivative of the whole function with respect to u if we write it out in words. Okay, derivative of the whole function with respect to u. And then we multiplied it by just the derivative of the u with respect to x. The chain rule will always involve those two pieces. Okay? So, before we do further examples here, let's scroll up and just give a basic description of the chain rule up here. Okay, I'm going to kind of skip over a discussion of the formulas for a minute here and just fill in the note. I'd like to describe in words what we just did in applying the chain rule. Okay, and we'll kind of keep this process in mind as we do future problems here. Basically, a couple of steps involved. So first, we made a choice for u. Okay, and in particular, the thing that we called u was the inside function. Okay, it was on the inside of our overall function, and then we went through the two-step process to find the derivative. Okay, starting with taking the derivative of the whole function with respect to u. Okay, same words that we mentioned below. Okay, and then we multiplied by the derivative of the u with respect to x. Okay, so every time that we do a chain rule problem, you're going to see these two steps every time we apply the chain rule.